Hi, I'm Stefan. Welcome to the TwoStack Developer channel. This is part 2 in our series on building smart contracts with sCrypt. Today, we are going to talk about how to run the smart contract that we have built. Then we will debug it. And after debugging, we're going to deploy the smart contract onto the testnet. After we've deployed it onto the testnet, we will briefly look at how we can build a follow-on transaction that would actually use the output from the transaction that we've deployed and spend from it. Let's get started. Now, if you recall, we started with this contract, which we called TwoStack demo, this one right here. Yeah. And we have these template variables, which basically sets up the template, the initial state of the template that we are defining, the output script template. Then there is this public function called lockSomeFunds, and the public function defines the locking conditions or our output script for the transaction that we will be composing. And if you recall, the arguments to this function, these are the spending conditions that are defined in the input script, which will be in the follow-on transaction we'll be composing manually towards the end of today's video. When you first declare a contract like this inside within the IDE or within Visual Studio, when you go to run, you will notice that you will probably be presented with this screen here because you don't have a launch JSON defined yet, a launch.json. I'm going to click on create launch.json here, and that will basically ask me to select what type of launch configuration I would like. I'm going to select debug script, and then I'm going to drop into this configuration here. I'm quickly going to close down the left-hand window here, just so that we can have the focus on this one here. Yeah. Here, the launch configuration contains these settings that we need to specify. I found that so by default it fills in this $file here, but I found that replacing this with workspace folder and then the name of the script, this is the name of the script, this works. The constructor arguments that we're looking at here are the template, basically are what the launch configuration will initialize our contract with here, right? So it will set the variable y for us, but it basically takes an array of variables, right? So if we have constructor configured here, then it basically takes an array, filling in from left to right the variables there. I'm going to initialize the array with 2. This pubfunc is basically the public function that we would like to invoke. Now, you can declare more than one public function within a smart contract, but we won't actually talk about the order of execution or what it means for us to have more than one public function in a smart contract today. Just take it for now that the smart contract in our launch configuration needs to be this name here, which is lockSomeFunds. So I'm going to fill that in. I'm going to say it's lockSomeFunds. And then the public function arguments, this basically here, we are now saying that, okay, for the purpose of running this script, we will need to specify the future input that we want to match against this output, right? Because we're essentially testing whether or not this smart contract can work. So let me say, I'm going to put in 1 here just for laughs. And this is going to be, this 1 here will be the X that is specified as the argument to the lockSomeFunds public function. Now that we have a launch configuration defined, I'm going to go back to the to open this window, and or rather the run debug panel on the left hand side inside VS Code. I'm going to click on the play button here to start the debugging process. Now this will just run through the code once. It's going to throw an error, which is essentially telling me that, oh no, the application is paused and there is an exception that has occurred here. I'm going to ignore that for now, and I'm going to run through, because what I really want to do is to get to the output window. Okay, here is our output screen or the debug screen that I actually was trying to get to. And the debug screen at the bottom panel here is showing us that we had a script evaluating to false. Let me pull this over to the left, that the script evaluated to false in the stack, right? And that is pretty much a failure. That means that with the parameters that we have specified, that the script actually fails. So I'm going to go back to the launch configuration. I'm going to change this number to, come on, I'm going to change this number to 2. And then I'm going to go back and run the script again. And this time we should see a normal execution. So if I view my debug console again, now it is telling me that execution has been successful, right? So that is the part where we've actually run. We've created a launch configuration and we have now run our script or our contract. Next, I'm going to show you how you can actually debug this. So I'm going to set a breakpoint right here with inside my public function and click on the play button again to essentially run in debug mode. And this, now the execution is halted right here on the inside my public function, and you've got the normal debugger. You've got a normal. You can basically now look at and inspect variables, local variables, right? So these things tend to be called either watches, so you can add additional watches here, or you can just look at what the current state of things are. So I can now see that the X that I've passed in currently has the value of 2. I can look at this, which refers to the contract instance. The contract instance has been initialized with the Y of 2. So this requirement here for inside the public function, this should pass now. So I can just press the play button again and then run it all the way through, right? And so this now works. There is one more thing that is useful, but this is actually only available if you have a premium subscription to the application. I'm going to debug again and run all the way through to, or rather, run this through to the breakpoint again. And once I've hit the breakpoint, there is a little button here which is basically going to view the script, all of the script variables, right? So this is actually what you see here now. This is the actual script, and I can step line by line through this script, which is actually the call stack, not the call stack rather. These are the operands and operators which will be pushed. These are the raw Bitcoin script operands and operators that will be pushed onto the stack for evaluation by the script interpreter. I'm going to quickly close this down because I want to show something else as well. So let me close. Come on, go away. Oh, come on. I do not want this window. Close it that way. Sorry, I'm not used to working with Visual Studio. I'm usually an IntelliJ guy. Anyway, now it's back. let me run this through, and then I can. I've also blown up the screen quite a bit so that the text is the font shows up well on the video recording. Okay, so now I've run it all the way through, and we can see that yeah, we've basically just run it all the way through at the moment. So that was debugging it. There is one more thing that I want to talk about, this debugging and the launch configuration. I'm going to go back to my Explorer, and I'm going to remind you that I actually compiled this JSON file in order to, or rather that when I compiled my contract, I generated this JSON file here, right, which is called debug_desc, either for description or descriptor. And I pointed out that this Bitcoin assembler, which is sort of the raw Bitcoin script, had this $y, which needs to be substituted in the template for the output. And then you have this entire script here. Now, because I've got a premium subscription to the platform or to the tool, the sCrypt extension, I'm able to go ahead and actually generate a, let me click here. I'm going to command click, or rather control click. You won't see the pop-up. There is actually supposed to be a context window, which you can't see right now. And I'm going to, in this context window, I can either use Command Shift P or click in this context window, click on compile a release build of my contract. And then the release descriptor file basically is an optimized compilation of the same assembler script. So you can see here that if I look at the debug version, right, it has a lot of opcodes in it. But if I look at the optimized release version of it, right, these are the benefits of subscribing. I'm not getting paid for this. I paid for, so this is not a paid advertisement for sCrypt. But I will say that this makes a big difference, both in visually being able to inspect what, for me at least, what the script actually does. In this case, it's very simple. It's pushing op0, which is also op-false, onto the stack. Then it is pushing whatever variable y we specified onto the stack. Then it's basically performing a nip, which is essentially going to yank the topmost element off of the stack. Then it will compare the second element from the top of the stack. So to the left of this on the stack, we would have pushed in maybe the 2 to compare with the y. So it's going to nip the second one from the top. It's going to kill this op0, and then it's going to have $y, and whatever is to the left of the script, which will be the 2, and then it's going to run num equal and compare those two things. Yeah? Okay. If you didn't follow it all what I just said with that, don't worry. Don't worry if you didn't follow what I just said. You can think through it yourself, maybe and manually work out how this evaluation will proceed. I think that would be helpful for learning. Okay. So yeah, I wanted to point out the fact that there is actually a release version of the descriptor that you have access to if you have a premium subscription to the sCrypt tool. There are other benefits, which includes, for example, the ability to evaluate the stack and to actually see what the script interpreter stack looks like, but I'm not actually going to talk about that today either. So we have now talked about how to run the script, how to debug it, and we have now quickly looked at, we've talked about running and debugging the script, and then we looked at the descriptors. Next, I'm going to want to talk about how we can actually deploy this. In order to get to deployment, we have to kind of remember that in trying to deploy the script, right? Let me switch over to the whiteboard. This explanation is going to require the whiteboard. Okay, before we actually talk about the deployment, I quickly want to make sure that we understand what it is that we're actually deploying. I'm going to call this transaction A here and transaction B, and then point out that the deployment that we're about to make, the IDE will actually push a complete transaction directly onto the testnet blockchain, so onto the testnet. So the IDE is essentially doing a lot more than what was just specified in the smart contract. If you recall, the smart contract deals only with this bit here, right? The smart contract for now is only concerned with specifying the criteria for output A1 that we are trying to construct. But when the IDE helps us to deploy our smart contract onto the testnet, we're essentially, there is a bunch of other stuff that the IDE will need from us in order to compose this transaction here properly. One of those things is we need, because the transaction needs both an input and an output, the IDE will need us to specify where we are spending from, right? So there is something over here, a UTXO, that we need to tell the IDE, okay, you can spend from this UTXO, which lives somewhere. So this is one of the things that we will need to specify for the IDE. Then, of course, we will need to specify that template variable that we, in Y, that we need. So we need to basically tell it what is the y that we would substitute. And I'm going to say, okay, substitute the value 2 for y in this case, right? And yeah, I wanted to point this out, so when I actually talk about the next part, this should be obvious. Okay, so let's talk about deployment. If I click on the left-hand side of the window, there is the sCrypt logo here, right, which will show me this panel with deployed contracts. I've already deployed this contract once before, but I'm going to deploy it again. At the bottom of our screen, you will notice that there is the Satoshi value displayed over here, right? And if I click on the Satoshi value on the bottom right-hand corner, it actually pops up. Now, those things come from somewhere, and I'm going to show you where those actually come from. The extension, the sCrypt extension itself, which I'm going to click on now to get to the sCrypt extension, has configuration parameters that we can set. So I'm going to go into the extension settings. There is a shortcut, a hotkey for this as well. But I'm just going to point out quickly that there is a private key in here, as well as if I scroll further down, you'll be able to see my premium subscription key, which I don't want you to see, right? But the only thing in here that is actually important for us is this key. And of course, there is this warning that, you know, this private key that is in here, which is actually needed by the IDE to help compose the transaction, right? But more than just compose the transaction, it needs to actually, this private key is obviously needed in order to properly create the spending, the spending input from the UTXO that we must have somewhere on the testnet. Now, the easiest way for us to get access to that particular UTXO is to take this private key, generate an address from this private key, and then send testnet bitcoins to that address associated with this private key. This will then allow the IDE to compose the transaction A that we are actually interested in. There is a command which will pop up this screen here, which is the command palette. You can also go on the menu and click on View Command Palette to see this. And if you then type in here just sCrypt, you will see all of the sCrypt functions that you can actually invoke. I'm going to select Show Transaction ID, and it's going to ask me for, I don't want transaction ID, sorry. Let me do that again. Command Shift P. I want to generate a Command Shift P. I want to generate an address for my private key, which is this one. And then in my output console, you'll notice here at the bottom, it has actually generated an address for me. I can now copy this address, go to my web browser. In the web browser, I'm going to go to a faucet. In this case, the faucet I'm using is testnet.satoshivision.network. Now I've already pasted my address in here, but I'm going to do it again. And I'm going to say that I'm not a robot. And before I do this, I'm going to switch back quickly to my Visual Studio Code so that you can see at the bottom right-hand corner, keep an eye on the number of Satoshis I have. I have 17,659 now. I'm going to flip back to the browser, and then I'm going to say, okay, send me some Bitcoin, right? It sent me the Bitcoin. And if I go back, I should see these Bitcoins reflected there now. Now I've got 19,000 Satoshis reflected inside. Oops, you didn't come back with me, right? So now you'll see that I've got 19,000 Satoshis reflected in the bottom corner on the right here. So that is basically how you would fund your the address associated with the private key that is configured inside the workspace. And this is important in order for the IDE to compose that transaction A that contains the public key that we're interested, the public key that contains the output that is essentially what we have built using our smart contract. Yeah? Okay, let me clean up the IDE here quickly. I do not want to be in the extension settings. I would like to be in the deployment screen. I no longer want to see the settings screen, so I'm going to close that. I don't need to see my launch configuration anymore, because now I'm going to double click on this 2-stack demo over here, and then you'll notice on the right hand side a new window has popped open. I'm going to close the left hand panel and just drag this window a little bit larger so that you can see what's going on in here. This is the deployment screen inside the IDE, and it's now asking me to specify the why, right? So the IDE is saying, okay, I'm going to build you this output script that I'm going to stick into this transaction A. What would you like the variable y, the template variable y, to be initialized with? I'm going to say 2. Then it's going to ask me, how many satoshis would you like to lock up in this output? Meaning that you should have inside your Satoshi balance at the bottom of the screen at least as many. I'm just going to say, okay, I want you to lock up maybe 1,600 Satoshis in that output, right? And then I can hit deploy. Everything should be set up now. Deploy. It's deployed the contract, and it's basically telling me now, okay, here's your transaction ID. I've deployed the contract onto the testnet, and now I can go back to the browser, and in the browser I can go to my block explorer, paste this in the block explorer. Remember to change to the testnet for the block explorer, so you don't try to find on the mainnet. And here we have one unconfirmed transaction, right? And the unconfirmed transaction, I can now go and look at this transaction to see basically what is this output, the first output that it's created. I'm looking at that now, and here I can see, right, it's the same output over here as what I had in my if I go back to my IDE and look at the release description for my code, then I can see that the assembler here in my release description matches what is actually deployed onto the blockchain, except that the $y variable has now been substituted with the 2 that we've initialized, but everything else here is the same. This of course now means that in order for somebody to claim this, the amount of money, which is this 1,600 satoshis that has been locked up in the script, they need to solve this by basically, they need to specify the input conditions or the input script that will allow this output script to evaluate, or rather the concatenation of the input and the output scripts combined should evaluate true on the script interpreter stack, and that will allow the transaction B that we will be building next to evaluate to true. So let me talk about that. Let me quickly reiterate where we are at the moment. We have just composed this transaction A with the help of the IDE. The IDE has helped us in the output of the script essentially compose OA1. OA1 right now contains the value 0 to opnip and then op num equal, right? Oof, that's a mean looking Q. Okay, let me just write a capital Q if I can stop fuddling. Okay, num equal, right? This is basically what is contained inside in the output script OA1 at the moment. Also, we have specified a private key, and using that private key specified an address, and then used a faucet to create a UTXO for ourselves over here, and that UTXO we basically funded with some satoshis using the faucet. So we used a faucet to put money in the UTXO, and then this transaction A, right, the IDE composed the transaction for us and deployed it onto the testnet. That's where we are at the moment. Now on to transaction B. what we'll be doing next is actually writing a program, or we'll programmatically be spending the output here. We'll be spending the output using an input B1. So we'll compose a new input B1, and we will also be composing an output B. So I'm going to say that the person who's trying to spend here is Bob, right? Bob is trying to create this transaction B. Alice here is basically locked up the funds for Bob with this condition here, with the locking condition here. And Bob now goes and looks inside his block explorer and realizes that, oh, hey, well, all I need to do is to prepend a 2 here to this entire output script, and then the whole thing should evaluate to true when it comes time to pass through the script interpreter. But I don't particularly like the fact that this is such a weak, anybody can spend this money. It's a pretty weak way of locking up funds. So Bob is going to basically create an output, and the output is going to just, he's going to take his money, pay to public key hash. He's going to create a P2PKH, like a standard locking output for himself. So he's going to move his money into a P2PKH output. Let's do that now. Let's go and grab Bob's funds and make it a little bit more secure for him. Okay, now if you remember, when we actually deployed our smart contract onto the test network, the transaction that the IDE created for us came back with this transaction ID, which we then looked up in the block explorer. So with this code, what we will basically need to do is we will need to supply the funding transaction for Bob, which is essentially the transaction we just created with the IDE. That transaction constitutes our raw input transaction. The hex for that transaction we will input here. We will go and look up the actual input index for Bob. And then, of course, we need to specify the input script that Bob will need to properly unlock the funds that Alice has sent to him. What's on chain? So I'm going to go to the browser. I'm going to open up their API tool, or rather the API documentation. There should be here a curl command for getting the raw transaction data. This is basically what I want, right? If I execute this curl command, then I can get back the raw transaction hex. And I'll just do that. I can look at the details for this transaction to see that the script that actually locked up the funds, this one is in input 1, 2, so it'll be input 0 because they're 0 indexed inside. And we can now set the output index to 0. And then once we've done that, we can set the input script for Bob. We already know that Bob basically needs to prepend a 2 to get the valid spending condition, and we're just going to input op_2, which is the same as just pushing the number 2 onto the stack. We can now conclude by broadcasting Bob's raw transaction onto the network. And that brings us full circle, all the way back to where we not really full circle, but it takes us all the way through to the other side of this journey that we just went through. So I can quickly recap what we did, right? We ran our smart contract. We then debugged the smart contract and deployed the smart contract onto the testnet. And now we finished off with actually composing a raw transaction in software ourselves that spends from this non-standard transaction that we just broadcast onto the testnet with the help of the sCrypt plugin or sCrypt extension inside Visual Studio Code. I hope that you enjoyed today's episode. This was part 2. You can check in the description down below for links to additional resources, including the source code for the application that I just used in order to do Bob's part of the spending transaction. Have a nice day, and I'll see you next time.